Then I would start a meeting.
Mm-hmm.
Right. Låt oss vänta några minuter, se om det är lite fler folk som kommer in här. Dorian,
Yep.
we wait a couple of minutes here, see if a little bit more attend to the meeting before we start, I think.
Yep,
so,
no problem. Yeah.
Yeah. And of course, we will record this, but it's good if we have a little bit more so that they don't miss the beginning, of course, for the agenda.
Yeah, no problem. Wait a few minutes. Yeah.
So you just installed your computer?
No, it's for some reason the Teams client was a very old version. I have no idea why.
Okay,
but
yeah.
I've heard from other people that they updated the Teams client and nothing worked anymore. So I probably waited for a long time for now to work.
Okay, I see.
Do we have partners and customers here, or what's the?
It will be partners. Partners only.
Partners, perfect. Yeah.
And yeah, I think we can. I don't think we need to wait any longer. I think we can start, and then we will have it recorded. And for all those that I have sent this out to, I will also send a link for this for the future. So if they're not available at the moment, then we can always look into it later. All right. So I'm just gonna backcheck. Sophia in the back. Are you recording it?
Yes, I'm recording.
Yes. Okay, good. All right. Okay, everybody, welcome to DevOps and also a little bit of a presentation of GitHub. And this is something that Dorian will present to us today. And hopefully this will make you more comfortable in and knowing what the DevOps is in Azure. And please go ahead and if you have any questions during the session, go ahead and ask it, and we will monitor your questions in this meeting. So please, Dorian, welcome, and yeah, you can present yourself.
Thank you very much. Yeah. So thank you all for joining the meeting. My name is Dorian Redak. I sit in Vienna, Austria. I work for the Center of Excellence within TD SYNNEX for the 4th year now. But I was already part of TD SYNNEX before, so I'm with TD SYNNEX about 8 to 9 years, approximately. My focus actually is on Red Hat Enterprise Linux. This is my primary partner, but as you will see, hopefully through this presentation, it's wise not to make too much difference between Microsoft and Linux, especially in regards to DevOps environments, where you will see that there's a lot of synergies here that will take place. Also, as Johan said already, I want to make this as interactive as possible. So I've prepared a little agenda. Yeah. What I first want to talk about is about the goals of DevOps. Why has it come to life? Which partners, which customers probably are ideal partners to contact if you want to implement DevOps environments, if you want to help them, support them in their journey to a modernized application environment, and so on and so on. Then we go through the Azure DevOps workflow. I will show you a few of the tools, explain what each of these tools is doing. Maybe a very important part for all DevOps environments is the cultural adoptions. So probably there's going to be changes how the company works because it comes from a very agile idea, this whole DevOps stuff, and hence the culture. So the department or the organization within the company might have to change or adopt a little bit to give an ideal ground for DevOps environments. Also, I'm going to talk about the technologies behind them and also the organizational structure, as I already said before. Yeah, and as I said before, I want this to be as interactive as possible. If there are any questions, I have a Q&A at the end if you want to But if you want to interrupt in between, you have some special questions, then don't hesitate to call. Please, Johan and Sophia, just interrupt me if I don't see it on the chat.
Of course.
Yeah. So what's the goal of a DevOps environment? The goal for implementing a DevOps oriented methodology within a company is to get an environment that helps to produce new software products. It's primarily software products, although you can take a lot of ideas for other product developments as well. The idea is to have this very fast, because we have to react to changes on the market as fast as possible. Time to market with a good setup DevOps environment should be really reduced to a minimum. It should be automated. So automation brings some benefits. One benefit is once it's tested and certified, it will always run in the same way. So you have less problems deploying new software into the environment, and also it makes it faster and it makes it more safe. And also the DevOps environment should be here to create high quality deployment, because during the deployment process, the software will be checked with several methods, so that the final product should be as safe and as stable as possible. Also, again, if I'm talking too fast, I'm very excited talking most of the times about the topic, so I might get fast. So if I'm getting too fast, please stop me and then slow me down a little bit. What could be a typical customer or an ideal customer that would use a DevOps environment? Primarily, as the name implies, more or less, it's software developing companies. Yeah, so companies that deploy their own software and bring this software to market. But also in larger IT environment or an IT department, you could develop software for internal purposes. For example, a banking application within a large bank or so. Yeah? This is also something where DevOps environment could be useful. And also startups and scale-ups. Startups and scale-ups usually start pretty small, even from employee perspective. So the cooperation between the team is very good already, which in larger environment always can be a problem. You have the network department talk to the firewall department, to the product development department. You have to translate between product development ideas into technical ideas and so on and so on. With startups, this is usually not the case. It's smaller companies, only a few people. So the interaction between these people is pretty large already. Also, the understanding for the other side is pretty large because the cooperation is very intense in organizations like this. The ideal partner, so who's going out to this end customer, is system integrators, so companies that already provide IT services. Traditionally, this is more hardware integration probably, or implementation of third vendor products, for example. But in this case, the system integrator can include their own ideas about how to implement the DevOps workflow. They can share their experience with the end customer and bring their ideas to the market. Also, cloud service providers, from most of the large cloud service providers, there are some workflows already in place, as is Azure DevOps that we're talking about. But for smaller cloud providers, it could be interesting to help them implement their cloud development of DevOps platform into their production. Also, consulting firms, as I said before, they usually have a lot of experience with DevOps, so they can share their experience with new customers and help them on their way to move to a DevOps environment. What are the key characteristics of partner or customers? As I said before, a good partner and customer would be a partner that already relies on software development. So whatever their primary goal is to put out a new software into the market. Also, it's good to find a partner customer that wants to improve efficiency and productivity. So probably they already do have a product that is developed for the internet or for the market, but they want to do this more oftenly. As I said before, time to market is very crucial and important here. So if you have a workflow that enhances your production, that really speeds up the process of getting new ideas into the project, getting new features into the project, then DevOps is a good place to start, or a good environment that helps you with doing that. Companies that do already have a lot of collaboration between the teams and do share teamwork, it's also a good ground for this. They should be open to adopt to new technologies, like we have to. Most of the new software developed is running on containers, so you have to adopt to a new containerized environment. If you're already familiar with it, then it's good, but usually at the time being, it's lots of work that has to be done to get into there. And also, as I said before, there's certain checks included in this whole pipeline, and all these checks enhance quality and security for the finalized product. This is how Azure DevOps workflow might look like. So this is from the perspective of Azure. Starting on the left side, you have the developer. The developer, what's missing in here, but I will get to this later on, is about creating the ideas, about planning the ideas, which can be done with Azure Boards. It's also an Azure tool. So the developer gets the idea translated from the product development team, and he starts developing this product. Usually it's not only one developer, usually you have a lot of developers, and these developers now need a way to coordinate their programming efforts. So it's not really not really practical that each developer writes a few lines of code, then sends this code to his neighbor, and he can then adopt this code, and then he sends it back and so forth. And this is not very useful in large environments. This is where we have Azure repositories for more Azure repos. Repositories is a place where you can store all your source code. The advantage is that the source code in there is also versioned. So if you're getting from an old version to a new version, the new version does not work, then you can easily go back to the old version, for example. It also enables you to develop certain product features in parallel. So you don't have to always synchronize between these two developers or the two or more developers, but you can develop in two different branches of this source code, and then later on merge it together. I will also get into these points a little bit deeper later on. This is just for the overview now. After writing the source code, it will be checked, and this is one of the areas where the security can be enhanced. We have very intelligent tools that look for code inconsistencies. So first of all, it looks if the code is written in a way that is standardized within the company. You're not using certain features of a programming language because it's not safe, and so on. So this is done in this first process. In the next process, which is Azure Pipeline CI, which is the continuous integration part, there you start building your application from the source code. And to do this, probably you want to get your application first into a development environment or into a production environment to make decisions between these. In this continuous integration workflow, you integrate all the necessary parts that make this application run. So for example, if you have a production database and a development database, they should share not the same credentials to log into the database. These credentials, these secrets, they should be stored in, for example, the Azure Key Vault. And within this Azure Key Vault, then once the application is deployed for development, the Azure pipeline would make sure that it gets the correct credentials for the development database. It will run this code analysis. It will do some integration tests, unit tests, and so on. And it will also define which hardware should be used to build this application. Yeah, there are certain, for development environment, probably you're using a smaller hardware, and for the production environment, you would use larger hardware to get the source code compilation done faster. Then we have the deployment part. In the deployment part again, this would take into consideration if you're developing for your staging environment, for a development environment, for your production environment. It will then download whatever has been generated by the continuous integration workflow. It will download and then push it up to the servers. Again, these servers for the development environment could be small servers because it's only 5 to 10 people probably testing there. And for the production environment, you would have the high performance servers that you would then release the new software to. Generally, releasing from staging to production environment or from a development testing environment to production is gated. So you would need a human intervention to really allow access from the staging environment to the production environment. So you can make sure you have a last check within your deployment pipeline that everything runs smoothly and someone has looked over it and given his okay that it's the software is ready for production. Finally, on the right-hand side, you have the Azure Monitor Application Insights and Log Analytics workspace. In this, you would gather all information from the running application. So you would see maybe some performance problems, some hopefully not a lot of errors, but still errors can occur. And so this is whatever comes out of this Azure of your product will be monitored, and then it will be put back into this loop, which points back to the developer. So we often see different representations of this. This is once again a summary of what the necessary steps are. So you would have a planning step, you would have the development step, continuous integration delivery. The testing will be done within this process, the deployment, feedback improvement, and security and compliance to check if anything goes wrong. So usually this is the view that is more commonly used or seen. It's not a one-step process. Usually it's a process that will be run over and over again. Hence, we see this infinity loop here. So you start from the planning phase via the build phase, via continuous integration, deploy, operate, and then again, continuous feedback. So you will usually see a type of this in running environments. It's not like it was before in a waterfall development where you would go once through all the development process. Usually in a way like this, you see it more like going over it over and over again and do final adjustments, small adjustments, but to keep the process of the service running all the time. Now let's look into the Azure products that are used in combination with this with the DevOps environment. And the first one would be Azure Boards. Azure Boards is something that you might, maybe the other graphic is a little bit more familiar. There are several ways to manage this. Azure Boards offers a Kanban board, for example. This is the place you would start gathering your ideas. You know, probably you can use any other tools, but this is already included. So the idea is to find the goals and the scope of your project. Yeah. So how large should the project should be? Who's going to be addressed with this project? You would also have how often do you want to deploy the software? For example, you can define, I want a new major version of the software deployed every 3 months or every year. How often should updates be done and so on. So this is only the basic idea, defining your key performance indicators, for example, for this process. The next thing is to identify the stakeholders. So who is internally sponsoring your project? Who will take the role of the program manager, the project manager, etc., and so on. But also, who's this application addressing? So who's going to be your end customer finally? Also important here in this step is probably to define a communication workflow. So who's going to talk to whom, who's responsible for this, who will take action if something does not perform and so on. So this should also be defined in the beginning. Next step, we have the resource planning. So how many team members should be working here? Which tools do you want to use? Which infrastructure, meaning which hardware in the background do you want to use, etc. And also, again, it's about defining responsibilities here. Who is responsible for deploying the hardware in the background? who is responsible to making sure that the certain resources are available at this time, etc., etc. Very important part also is risk management. What happens if you're late on certain milestones? What happens if the project or the product itself is not really suited in the market? So will you take it offline after 3 months or half a year, and so on? So this is all considerations that should be considered in the planning phase. And finally, but not last, is security and compliance, which is always very important. So before the product is released, before it is used, it has to be checked by security department and compliance department if it's against any rules within the company. And yeah, monitoring feedback we already had in other parts. Next step is the deployment part, the development part, sorry, the development part, which is part of, which is handled by Azure Repos. Repos, as I said before, is here to store your source code. Source code can be written in any language. Repos is not really confined to Microsoft preferred languages. It's open for everything. In these source code repositories, as I said before, you can do branching. So you can have develop several versions or several features within your project in parallel. So one is working on the, I don't know, identification part or the authentication part, and another one is another department is working on the graphical interface. The other one is working on the databases and so on. But all this can be worked on in parallel. And every time something is changed or it's put back, this is a so-called merge. So if one branch is finished doing its implementation, this software part is merged into the mainstream of the software development, and then can be tested against the other modules that are available here. Speaking of this, usually in DevOps environment, you're not using large monolithic applications. Usually you're going microservices, where each microservices can be developed in its own space. The only thing that has to be identified in the beginning, in the planning phase, and agreed on, is how that these smaller microservices can communicate with each other. Usually it's HTTP REST at the moment, but even there you have to define a few things. Next thing, as I already mentioned, is versioning. Versioning gives you the possibility to define certain milestones at which this application can be deployed. But it's also a way to look back in history. So maybe you developed into the wrong direction. After 2 or 3 months, you're noticing that this is not the right way to go. Then you can easily move back to an older version of this environment. Or you make a change and you notice that this change the correction was not properly and it's still not working, and it's better to get back to an older version. Then you can easily go back to an older version. Searching is also very easily done in here. Searching gives you the opportunity, for example, to make different views between 2 versions of the applications. So you can check in this old source code, I have this version, in the new one, I have this. And you can then search through all your history. You can search back and try to find a solution or to find the error. Code reviews are also done. Code reviews can be done by other team members. So you have a junior developer who's just starting out, and before he is allowed to put his source code into the production environment, the senior developer would look through this code, would test the code, and see if it fits into the current solution. Also, yeah, okay. Leave it this way. Then we come to the continuous integration part, which is part of Azure pipelines. Azure pipelines consist of several components. So the pipeline itself consists of several stages. Stages, as I mentioned before, could, for example, be a development environment, a staging environment, and a production environment. So this could be seen as one stage. And within this stage, you define certain jobs. A job can be run via an agent, or a job can be run by itself. So a job probably could be how to set up the database, how to prepare the hardware in the background, how to compile the software if it's in a compiled language, and so on and so on. So there's several stages, and within these stages, then you have minor tasks. So for the database, this could be set up the database, create the credentials to connect to the database, create a basic database structure, and so on and so on. So this is how the pipeline is the components of the pipelines. These are. A pipeline can be run automated, or it can be triggered. A trigger can be, for example, if someone makes changes to the repository, then automatically a new version will be run through this pipeline, and the new version of the application will be deployed to the development testing environment, for example. But it can also be triggered and by a manual intervention. It can be done scheduled each Saturday in the evening, I don't know, it will be run or manually triggered by a person. The usual way currently is to do this via a trigger from a repository. So once the repository gets updated, it will automatically start building the new version and deploy it to the development and test environment. Static code analysis I already mentioned. It will look through the codes if there are obvious errors in the codes. For example, if you have an endless loop in your programming structure, then usually these static code analysis tools are pretty capable of finding this. You could have multiple pipelines, obviously, for each software product, or you have one product, one for the production environment and one pipeline for the development environment. That's really up to how you're going to use it. Yeah, so this is the stages that you would have. You have the source stage, the build stage, the code analysis, then the test stage, and finally the package stage. In the package stage, if you're talking about containerized technology, for example, then in the package stage, all the software would have been compiled. It would have been put into a zip file, for example, and this zip file would then be compiled, would then be copied to the container where it could then used from the application with the necessary dependencies. Okay, that then would be the continuous delivery for this Azure pipeline. You have release pipelines where you would, as I said before, deploy to the staging environment, to your production environment, and so on. And in this deployment phase, if you're, for example, deploying this application to Azure, you would define which virtual machines, for example, should be used to run this environment. As I said before, you could have a development environment that you probably would use only on-site, on-prem, in your own data center. Then you could define how to connect to the underlying hardware or to the underlying hypervisor, how to set up the virtual machines that would be used, how to set up the containers that would be used to deploy this application. But also, if you're deploying to Azure, you could then probably define your virtual machines run on Azure. You could deploy it to a Kubernetes environment. You can deploy it to OpenShift, etc. So this is everything is open, and this is handled in the continuous delivery process, where the finalized product that has been created from the continuous integration step would then be deployed to your environment. Also here, approval gates. So before anything can be deployed into the environment, someone has to approve it for the production environment. Yeah, also you have to check financial problems, for example, or you have to make sure in advance that you have enough Azure credits to run your environments, and make sure that there's nothing running that is not really needed. Yeah, so also what would be used here is Azure Monitor, as I said before, to see how your resources are used, if they're used efficiently or not, and yeah, certain other tools as well. The stages here are the release stage, deployment stage, monitoring, logging, as I said already, and security and compliance again for checking. Yeah, so and finally, your software has been deployed, and this is where the loop closes. So you would now go back maybe to your Kanban boards, to your idea boards, when you noticed from monitoring or logging events that something is not working properly or could be enhanced. There's complaints by end customers that the application is not performant enough, or it's not. The management is, or the usage is not logical for the end customer. Then this would flow back into the Kanban board, and then in a second stage, this loop will be run again. Now let's also come to some cultural changes, organizational changes that might be needed to have a properly running DevOps environment, as it is not only a technical challenge. We've seen some technical challenges here, but I think it also needs some social adoptions within the company. Usually you have two parts. So you have a development department and an operationals department, and usually they don't work as good with each other as it's presented here with these two wheels. The perspective for a networking guy, for example, is he wants a stable environment. So he wants as little and as less changes as possible, because on the weekend or if he has got 24 standby and he has to go to the company on the weekend, he's probably not going to be very happy about this. Also, most of the times, the operations department is somewhat customer facing. So all the complaints from the customers usually end on their side, and they have to troubleshoot them. In a DevOps environment, the operations guy is only here for running the environment, so he cannot look into the source code and so on. So from the developer perspective, they want to quickly react to market changes all the time. Yeah, they are market driven. They cannot say, I have to wait for the next version of this hardware or for this product. We have to deploy it now because we want to keep time to market as short as possible. They also have to react to software changes. So if a new version of their software development platform, their framework, if there's a new version, they have to adopt quickly to this. And so you see the two sides. Yeah. The developer also has to talk to the business developments. He has to translate their ideas into a technical product, and so on. So these sides are more or less always in conflict with each other. So it doesn't make a sense to make a developer to an operations guy and vice versa. It doesn't make a sense to make an operations guy to the developer. And therefore, it's pretty useful to have a so-called DevOps engineer. The DevOps engineer would only be responsible for communicating between these two, which in a large environment, in a large company is absolutely mandatory, I would say. For smaller environments where we started in the beginning with these scale-ups, I think for them it could be done in a traditional way, but just smaller groups can communicate a lot easier. Yeah, so let's see the cultural changes within the company. Yeah, so about collaboration and communication. Yeah, maybe these are some steps that could help start the process of integrating the development or the DevOps methodology in your company. As I said before, development teams and operational teams, they don't really talk to each other, as they have two different backgrounds from where they're coming from. So to get them work together better, there's a lot of communication needed. Yeah, so it's really necessary to break down these silos, to get into an open conversation, into an open communication, and to share this responsibility. So if there's a trouble on the weekend, there's probably going to be a 24/7 standby from the developers as well to get this up and running. Both sides or all included parties have to learn probably. DevOps is nothing that you can integrate by installing a tool. DevOps has to be living. Yeah, so you have you have to continuously learn. Yeah, then there's gonna be problems. There's gonna be failures. Yeah, not any a software that is developed is never error free. So there's gonna be errors and there's gonna be failures. You have to adapt to this, and you have to find a way to easily overcome this and start talking again without all this finger pointing. Very crucial part is automation. Automation, as I said before, also comes with standardization. So standardization means that whenever you are deploying this environment, it looks always the same. So from one day to the next, you know, if I'm redoing this deployment, if I'm redoing this integration, it will look the same. So there's gonna be no surprises. If this would have been done manually, then maybe one of the guys has the creative idea of checking the wrong checkbox and nothing is working again. This is why it's very important to automate everything in here. Always keep in mind that the customer is what we're working for. So the customer has priority. So the feedback from the customer also has to be integrated into this creation, into this DevOps loop, so that we can satisfy his needs and his ideas, which probably hardens our market position. One thing important also is decentralized decision making. If you always have to wait for the approval from the CEO, then it's probably not, you're gonna not be fast in developing your new product for the environment, for the market. So you really need to give permissions to the right places to speed up this process. Yeah, as I said before, leadership buy-in is very important for a DevOps implementation. It can, in a small company, as I said, it's not a problem, but if you want to have a DevOps implementation, then you really need the backing from the C level. Otherwise, it's going to be really difficult. It will involve a lot of training and development, which I think is actually really good because employees can enhance their skills, learn something new, get into new stuff and so on, and not caught in their day-by-day treadmill they're usually working in. Get your partners, get your consultants in. They implemented a lot of DevOps projects probably, and they can help here with coaching. Cross-functional teams we also see afterwards. There's different approaches on how to organize a company. Cross-functional teams could be one, but probably is also not maybe not ideal depending on the situation. Yeah, and always look back what already have been done before, what has been achieved, and so on and so on, which also shows again this looping structure. Here we have a little bit of a comparison for cross-functional teams, for example. Usually in the cross-functional team, you have a close cooperation between development and operations team. So although the operations guy did not develop this software, as he has good relations to the developers, he also feels responsible and accountable for whatever happening in this product. Yeah? As I said before, there's gonna be failure, but if he identifies with the product itself, he's gonna be by himself probably contacting the development team and start new conversations on this. Generally, cross-functional teams are rather small because the interaction should be very good, which makes it a little bit of a challenge if you're going to large-scale environments where you have only a few guys sitting there for this department and from the other department. And so, yeah, again, communication is very important here. Platform teams would be teams that only responsible for one project. Working together on it could be better, but as as these platforms teams grow pretty large, again, you would have probably some communication problems in here. Also, you would have to find a good coordination between these single platform teams so that everyone gives the resources that are really necessary. Outcome would be a hybrid model, but all hybrid models are some sort of workaround, some probably also not the most ideal part. Yeah, you have to look into this, how this, which structure suits a company, again, is very dependent on the company itself. As I mentioned before, I talked about the DevOps engineer. The DevOps engineer, especially in large environment, is a separate role that really should exist. This should neither be a guy from the development department nor from the operations department, though he should have skills in both of them, which is probably pretty hard to find. But sooner or later, this should be the goal for this guy. He also should show some leader skills because he's probably got to talk to a lot of people from different departments, convince people, and so on. So he's more a mediator between these two parties, and that these two parties that are not always working streamlined on one project, probably. Talking about technologies, and probably something the DevOps engineer should be pretty confident with is version control. As I said before, there's not only one tool, but the standard tool is Git. Git, probably you heard from GitHub and GitLab and so on. GitLab, I think I have detailed slides on this. Yeah, I have detailed slides. Just going quickly through this here. So you have version control, you have Linux, because Linux is the standard platform for containerized environments. The DevOps engineer should be confident in coding a little bit, so he doesn't have to be a die-hard programmer, but he should understand some basic coding basics, like what is a class, what are methods, and so on. Maybe should know one or two programming languages. Also, agile development, here comes the term Scrum and Kanban boards and so on, should be familiar to him. So he should be included in the operations part, obviously. He should know what containers are, what Kubernetes is, what OpenShift is, what infrastructure as code is, maybe understand a little bit of automation. Maybe once heard about Jenkins, which is the de facto standard for pipelines, and monitoring and so on. So this is quite a large role for a single person. So it's going to be probably a more experienced person that's fulfilling this role. Let's go a little bit into version control again. I want to have this a little bit more in detail. So the de facto standard here is Git. Git is, as the presentation says, is a free open source distributed version control system. It's capable of doing very small projects to very large projects. Yeah, and it really shines with speed and efficiency. Yeah? So I think everyone is using Git in some sort of Git in the background. It's easy to learn. Okay, this is arguable, but it's lightning fast and really works nice. It has become the de facto standard, so everyone is using Git. It was developed by Linus Torvalds, who is also happens to be the creator of Linux. And important for me, I think, is always don't see Linux as a competitor in this market here. Or see the open source the environment as a competitor in this environment here. Yeah? Most of the tools that are used by everyone actually come from the open source environment. What Azure has done here is a really nice integration of all these tools into one workflow, and this is the real benefit here that I see here to use Azure. What programming languages should he probably know a little bit about this? There's tons of resources on the net if you want to get familiar with a programming language. There's tons of information out there. Maybe look for something like top languages to learn in 2025, because also, as everything else changes, also the preferred technologies are changing a lot. From a Microsoft perspective, obviously C#, .NET, Python, Java are the main go-to development languages in the moment. From a Linux perspective, it's C, C++, Python, and Java. I think especially Python is very important. You see a lot of Python also in data and AI. This is very important. It's a pretty good readable language, easy to learn, at least the basics. So I think this could be a good start, but whatever. So if you confident in one programming language, you probably understand all the other programming languages as well pretty fast. Technology that's really important here, which I say is container technology. Containers at the moment only run on Linux. I think there's some Windows and macOS implementations there. There's some ways to make containers run on Windows and on macOS, but they are using virtual machines in the background. So natively, containers run primarily on Linux. What's the difference between a container and virtualization? You've probably also seen this often enough. Virtual machines in general have a large overhead. So because for all, maybe I'm going to draw a little. Can I draw here? No. Sorry. Yeah. So within all virtual machines, you would have a guest operating system running, which is shown on the lower right virtualization part. Yeah. So you have first the operating system. On this operating system, you have the hypervisor running, partially combined nowadays. But then within each of these virtual machines, you have the application and the guest operating system running. So you have in this case, 3 times the guest operating system running. Probably it's always Windows 10 or Windows 11, I don't know. So you have all the binaries installed 3 times, which is an absolute overhead for this. Hence, you see usually in a virtualized environment, you see 10 to 20 virtual machines per physical server. Also, the dependencies within the virtual machines is somewhat difficult because you can only install one application library on one virtual machine. Otherwise, they would conflict each other. Yeah. Using containers, you get rid of a lot of these handicaps. It has very little overhead because you're only running the operating system. There is no hypervisor sitting in between that would slow down performance, etc. Yeah? Each container is individually designed. So if you're running a container that serves the web, why would I install Microsoft Office in there? The web server does not need Microsoft Office, for example. Yeah? Or you would not install probably the database within the same container as you're running the web server, and so on and so on. So this makes it a lot more flexible and a lot probably also more stable, and it gives you a lot more performance. So usually with containers, you're talking about 100 to 1,000 containers per physical server. At least a factor of 10, I would say, generally speaking. And also you could have multiple dependencies. As a container is very small and you want to test 2 different libraries within the same application, well, then just start another container. It's not consuming that much space. So it's easy to run several versions and have multiple dependencies checked. Very important also is jumped again, sorry. Is Kubernetes. Kubernetes is an orchestration platform for containers. Go to the next screen. So more or less every of these blue dots you see in this screen is a separate container. Managing these containers manually, starting them, looking if they're still running, redeploying them, etc., is a very difficult task. So you need some automation for this. And this is where Kubernetes was developed for and really shines. Kubernetes is part of most containerized environments or OpenShift, the platform, for example, relies on Kubernetes as a platform and so on. So what does this container platform? It checks that all the containers are alive. So you don't have to manually check in your log files or whatever. It will check if this container is still running, up and running. You can define how it is checked, but generally it's just a normal test if it's available via the network. And if application goes down, or if one of these containers goes down, then it will Kubernetes will automatically restart a new container for you. You can also define that I want this application to be running in 10 containers, and if one of these 10 containers goes down, maybe one session gets lost, but the general availability of the product is still there. Hence, you can, and then afterwards, Kubernetes will look that this missing container is started again. Also, if there's if you're consuming more than you actually need, so you have only a few hundred users, but you have 10 containers running for these 100 users, then Kubernetes will notice that these are not used properly. They are not. There's an overhead in hardware provided here or in containers provided here. Then it will scale down the containers to a level where it makes sense for this type of application. Kubernetes also provides network connectivity between the containers, but also to the outside. It manages the credentials. There's a credential store like Azure, what was it called before? Key store that we had before, and it will manage all the secrets in a safe place. It will build the containers. It will build all these deployments. So how many containers of this type should be running, you can define in this deployment style. Resource planning, I already mentioned. If an application has too many containers running, it will scale down. If it notices that the response times is very low for certain containers, it will start a few other containers to compensate for the additional performance request. So this already brings us more or less to the end. So I have a small summary here. Azure DevOps is a suite of development tools that should help in planning, coding, and building and testing and deploying new applications. It should support in enhancing the collaboration and the communication between the different departments. It takes a lot of these automation tasks from you, and it supports you in the continuous delivery of your products to the market. And again, most important thing again is here, reduce time to market in these environments. I also have generated, which should be on the next slide, some keywords or buzzwords. By no means anyway exhaustive. This should help you probably in the talk to the customer. If you come about this buzzwords, about these keywords, this probably has something to do or is maybe a good partner. This may be a good project to talk about Azure DevOps here. Also, if you need support on any of this, please feel free to contact us via your usual plans. I will have my email address, I think, in the end of the presentation, so you can contact me directly for the COE if you want access, or via via your business manager. Just mentioning these words here is Podman, Docker, Kubernetes. Kubernetes we already heard. Podman and Docker are administration tools that are pretty exhaustively used by developers on local environments. So Podman and Docker are both good for local environments. I would say, if you're going into production, you want to run multiple containers with all the benefits I mentioned before, then Kubernetes is the way to go to. Kubernetes, we already mentioned. App modernization, I briefly touched today. This is about microservices, more or less. So usually you have old applications or in legacy applications, there were really large applications where we had one monolithic block of the whole application, where it's difficult to change the code in between because the dependencies are very high. With application modernization, going to a microservices environment, you have one service that does only one thing, but it does this thing very good, and then you have an external connection to this, how to talk to this. Agile and Scrum are already also discussed, which is to project management types of forms that can be used to help bring new products to the market. Jenkins is the tool that is used for pipeline automation and so on and so stuff. Maybe a word you stumble upon is ELK. This comes from the acronyms Elasticsearch, Logstash, and Kibana. Kibana is more or less replaced by Grafana now, but still the acronym is still used pretty often. Code repository, we had Nagios is for monitoring applications. For each of these topics I mentioned here, you will find several others on the internet. This is maybe just, as I said, the keywords. So if you stumble upon them, Argo CD is also another pipelining tool. Ansible Terraform is for automation. GitLab, GitHub, probably you stumbled upon because lots of projects are hosted there. Maven is a pipelining tool for Java and so on and so on. So yeah, hopefully this rings a bell. Maybe once you hear these topics, you know roughly what it is about, and contact us, and we can hopefully support you then even better. Yeah, so this brings me to my final slide. I would now open for Q&A. If you have any questions, you can talk now. You can see my email address here. You can go through Johan, whatever you want to. And then maybe you can open the phone, or maybe is there something on the chat?
It's nothing in the chat. Johan, do you want to add anything?
No, it's okay. I think you covered everything, Dorian. Thank you very much for that. I do want to say though that we are in a position where we have this in sort of practice in January. So that would be David that will take over and present it how it could look and how you can set it up and how it works. Yeah.
Mm-hmm.
So yeah, that is what I want to say. So, but I mean, if there's no other questions, then we should wrap it up, I think.
Perfect. Or maybe we should stop the recording, and then, because in the other countries we have problems with GDPR if people ask questions while still recorded.
I see, Dorian.
We have not actually, because it's not possible for people to be vocal in this meeting. So they need to enter it in the chat, but we will take that away from the actual recording if we have this. So
perfect.
But I think people might reach out to Johan if they have any questions, or to you directly, Dorian.
Perfect. Mm-hmm. Then thanks everyone for listening.
Thank you. Thank you very much, Dorian.
Yeah.
Thank you.
Thank you and bye.
Bye.
Thank you. Take care.
Bye.
Bye.